When penetrating barrier walls in hazardous or classified areas, several codes and standards apply, primarily NFPA 70, the National Electrical Code, and NFPA 85, the Boiler and Combustion Systems Hazards Code. Regarding sealing requirements, NEC Section 501.15b2 states that penetrations of fire resistance rated walls shall be sealed with an approved method. NFPA 85 Section 6.52.12 specifies that openings in fire barriers that may allow the passage of combustible gases shall be effectively sealed. For natural gas Class 1, Division 2 areas, NFPA 85 Section 6.52.12 reiterates that openings in fire barriers shall be effectively sealed to prevent the passage of combustible gases, and NFPA 85 Section 6.52.13 adds that electrical wiring passing through fire barriers shall be protected from mechanical damage where required by NFPA 70, the NIC. Several methods are approved for sealing conduit penetrations in barrier walls. These include firstly, intumescent putty, which expands upon exposure to heat, sealing the opening around the conduit. Secondly, compression-type seals, which use a flexible or rigid seal that compresses around the conduit to create a tight fit. Thirdly, foam-type seals, which involve applying a prefabricated foam gasket or sealant around the conduit to fill the opening. And fourthly, combination seals, which utilize a combination of methods, such as an intumescent putty with a compression-type seal. Other considerations include the conduit type. Use conduits that are approved for use in hazardous areas, such as rigid metal conduits or explosion-proof conduits. For installation, install conduit securely and avoid creating gaps or voids around the seal. Inspection and testing are also important. Regularly inspect and test seals to ensure they are maintaining their integrity. To effectively prevent the passage of natural gas from a Class 1, Division 2 area to unclassified areas, the penetrations through the barrier wall must be properly sealed using an approved method. Intumescent putty, compression-type seals, foam-type seals, or combination seals are all acceptable options. Additionally, it is crucial to use appropriate conduit types and ensure proper installation and maintenance of the seals. When dealing with Class 1, Division 2 locations and barrier penetrations, adherence to specific requirements detailed in NFPA 70 and NFPA 85 is paramount. These standards outline stringent guidelines for sealing penetrations to prevent the migration of combustible gases and maintain the integrity of fire-rated barriers. The NEC Section 501.15b2 provides a broad mandate for sealing penetrations in fire-resistant rated walls, emphasizing the use of approved methods. This section serves as a foundational requirement, highlighting the importance of preventing the spread of fire and associated hazards through openings in walls designed to contain fire. NFPA 85, specifically Section 6.52.12, reinforces this requirement by explicitly stating that openings in fire barriers that could allow the passage of combustible gases must be effectively sealed. This is particularly critical in environments where natural gas or other flammable substances are present, as any breach in the barrier could lead to a hazardous accumulation of gas in unintended areas. Moreover, NFPA 85 Section 6.52.13 addresses the protection of electrical wiring that passes through fire barriers. It mandates that this wiring be protected from mechanical damage, referencing the requirements outlined in NFPA 70, the NEC. This provision ensures that the electrical systems themselves do not become a source of ignition or contribute to the spread of a fire. Several methods are available for effectively sealing conduit penetrations in barrier walls, each offering unique advantages and suitability for different applications. Intumescent putty is one such method. This material expands significantly when exposed to heat, filling any gaps or voids around the conduit and creating a tight, fire-resistant seal. Its expansion properties make it particularly effective in preventing the passage of both fire and combustible gases. Compression-type seals represent another approach, employing a flexible or rigid seal that compresses around the conduit to achieve a tight fit. These seals are designed to maintain their integrity under various environmental conditions and can be particularly useful in situations where movement or vibration is a concern. Foam-type seals offer a third option, utilizing prefabricated foam gaskets or sealants to fill the opening around the conduit. These materials are often easy to install and can provide effective sealing against both fire and gas penetration. Combination seals, as the name suggests, combine multiple sealing methods to achieve enhanced protection. For example, an intumescent putty might be used in conjunction with a compression-type seal to provide both fire resistance and a tight mechanical seal. In addition to selecting the appropriate sealing method, several other considerations are crucial for ensuring the effectiveness of the barrier penetration. The type of conduit used is an important factor. In hazardous areas, it is essential to use conduits that are specifically approved for such environments, such as rigid metal conduits or explosion-proof conduits. These conduits are designed to withstand the rigors of hazardous locations and prevent the escape of sparks or flames. Proper installation of the conduit and sealing system is also paramount. Conduits should be installed securely, and care should be taken to avoid creating any gaps or voids around the seal. Any such gaps could compromise the integrity of the barrier and allow the passage of gas or fire. Regular inspection and testing of the seals are essential for verifying their continued effectiveness. Over time, seals can degrade due to environmental factors, mechanical stress, or other causes. Regular inspections can identify any signs of damage or deterioration, allowing for timely repairs or replacements. Testing methods may include visual inspections, pressure tests, or other techniques to ensure that the seals are maintaining their integrity. In conclusion, preventing the passage of natural gas or other combustible substances from a Class 1, Division 2 area to unclassified areas requires a comprehensive approach to sealing penetrations and barrier walls. This approach must include careful consideration of applicable codes and standards, selection of appropriate sealing methods, proper installation techniques, and regular inspection and testing. By adhering to these principles, it is possible to create effective barriers that protect against the hazards associated with flammable gases and maintain the safety of personnel and equipment. The selection of a suitable sealing method for conduit penetrations in hazardous locations hinges on several factors, including the specific requirements of the application, the type of conduit being used, and the environmental conditions to which the seal will be exposed. Each method has its own advantages and disadvantages, and a careful evaluation is necessary to determine the best option. Intumescent putty, for example, is particularly well suited for applications where fire resistance is a primary concern. Its ability to expand upon exposure to heat makes it an excellent choice for sealing penetrations in fire-rated walls or other areas where the spread of fire must be prevented. However, intumescent putty may not be the best option for applications where the seal will be subjected to significant movement or vibration, as the expansion process could be disrupted. Compression-type seals, on the other hand, are often a good choice for applications where movement or vibration is a concern. These seals are designed to maintain a tight fit around the conduit even when subjected to these forces, ensuring that the integrity of the barrier is maintained. However, compression-type seals may not provide the same level of fire resistance as intumescent putty. Foam-type seals offer a balance between fire resistance and flexibility, making them a versatile option for a variety of applications. These seals are often easy to install and can provide effective sealing against both fire and gas penetration. However, foam-type seals may not be as durable as other options and may require more frequent replacement. Combination seals offer the best of both worlds, combining multiple sealing methods to achieve enhanced protection. For example, an intumescent putty might be used in conjunction with a compression-type seal to provide both fire resistance and a tight mechanical seal. These seals are often the most expensive option, but they can provide the highest level of protection. In addition to the sealing method itself, the type of conduit being used can also affect the effectiveness of the barrier penetration. As mentioned earlier, it is essential to use conduits that are specifically approved for use in hazardous locations, such as rigid metal conduits or explosion-proof conduits. These conduits are designed to withstand the rigors of hazardous locations and prevent the escape of sparks or flames. The installation of the conduit and sealing system is also critical. Conduits should be installed securely, and care should be taken to avoid creating any gaps or voids around the seal. Any such gaps could compromise the integrity of the barrier and allow the passage of gas or fire. Regular inspection and testing of the seals are essential for verifying their continued effectiveness. Over time, seals can degrade due to environmental factors, mechanical stress, or other causes. Regular inspections can identify any signs of damage or deterioration, allowing for timely repairs or replacement. Testing methods may include visual inspections, pressure tests, or other techniques to ensure that the seals are maintaining their integrity. Proper documentation is also crucial for ensuring the long-term safety and effectiveness of the barrier penetration. This documentation should include details about the sealing method used, the type of conduit installed, the date of installation, and the results of any inspections or tests. This information can be invaluable for future maintenance and troubleshooting. In summary, effectively sealing conduit penetrations in barrier walls and hazardous locations requires a comprehensive approach that considers all relevant factors, from the selection of the appropriate sealing method to the proper installation and maintenance of the system. By following these guidelines, it is possible to create effective barriers that protect against the hazards associated with flammable gases and maintain the safety of personnel and equipment. Understanding the nuances of hazardous location classifications, particularly Class 1, Division 2, is essential for implementing appropriate safety measures. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 locations are those where flammable gases or vapors are handled, processed, or used, but are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. In a Class 1, Division 2 environment, the likelihood of flammable gases or vapors being present is lower than in a Class 1, Division 1 environment, but the potential for explosion or fire still exists. Therefore, it is crucial to take appropriate precautions to prevent ignition. Sealing conduit penetrations in barrier walls is one such precaution. By preventing the migration of flammable gases or vapors from a Class 1, Division 2 area to an unclassified area, the risk of explosion or fire is significantly reduced. The National Electrical Code (NEC) provides specific guidelines for electrical installations in hazardous locations, including Class 1, Division 2 areas. These guidelines are designed to minimize the risk of ignition and ensure the safety of personnel and equipment. In addition to the NEC, other standards, such as those published by the International Electrotechnical Commission (IEC), may also be relevant depending on the specific application and location. These standards provide additional guidance on the design, installation, and maintenance of electrical equipment in hazardous locations. When selecting a sealing method for conduit penetrations in a Class 1, Division 2 area, it is important to consider the specific requirements of the NEC and other applicable standards. These standards may specify the types of sealing materials that are permitted, the methods of installation that are required, and the testing procedures that must be followed. It is also important to consider the environmental conditions to which the seal will be exposed. In some cases, the seal may need to be resistant to chemicals, temperature extremes, or other harsh conditions. Choosing a sealing method that is appropriate for the environment will help to ensure its long-term effectiveness. In addition to sealing conduit penetrations, other safety measures may be necessary in a Class 1, Division 2 area. These measures may include the use of explosion-proof equipment, intrinsically safe circuits, and other techniques designed to prevent ignition. A comprehensive safety plan should be developed for each hazardous location, taking into account the specific risks and hazards present. This plan should be reviewed and updated regularly to ensure its continued effectiveness. Training is also essential for personnel who work in or around hazardous locations. These personnel should be trained to recognize the hazards present, to follow safe work practices, and to respond appropriately in the event of an emergency. Regular training can help to prevent accidents and ensure the safety of all personnel. In conclusion, working in or around hazardous locations requires a thorough understanding of the risks and hazards involved, as well as a commitment to implementing appropriate safety measures. By following the guidelines provided in the NEC and other applicable standards, and by providing adequate training to personnel, it is possible to minimize the risk of explosion or fire and ensure the safety of all personnel and equipment. The integrity of barrier walls in hazardous locations is paramount to preventing the spread of flammable gases or vapors and maintaining a safe environment. A barrier wall, in this context, serves as a physical separation between a classified hazardous area and an unclassified, non-hazardous area. Its primary function is to contain any potential release of flammable substances within the classified area, preventing them from migrating to areas where they could pose a risk of ignition or harm to personnel. The construction of a barrier wall must adhere to specific standards and regulations to ensure its effectiveness. These standards typically address the materials used, the methods of construction, and the fire resistance rating of the wall. The materials used in a barrier wall should be non-combustible or have a limited combustibility to prevent them from contributing to the spread of a fire. Common materials include concrete, masonry, and fire-rated gypsum board. The method of construction should ensure that the wall is structurally sound and able to withstand the pressures that could result from an explosion or fire. This may involve reinforcing the wall with steel or other materials. The fire resistance rating of the wall indicates the amount of time that it can withstand exposure to fire without losing its structural integrity or allowing the passage of flames or hot gases. The required fire resistance rating will depend on the specific hazards present in the classified area and the proximity of the wall to other structures or areas. In addition to the wall itself, any penetrations through the wall, such as those for conduits, pipes, or ducts, must be properly sealed to maintain the integrity of the barrier. As discussed earlier, there are several methods for sealing these penetrations, including intumescent putty, compression-type seals, foam-type seals, and combination seals. The choice of sealing method will depend on the specific application and the requirements of the applicable standards. Regular inspections of barrier walls are essential for identifying any signs of damage or deterioration that could compromise their effectiveness. These inspections should include a visual examination of the wall for cracks, holes, or other defects, as well as a check of the seals around any penetrations. Any damage or deterioration should be repaired promptly to restore the integrity of the barrier. In some cases, it may be necessary to test the fire resistance rating of a barrier wall to verify that it meets the required standards. This may involve subjecting the wall to a controlled fire and measuring the time it takes for the wall to fail. The results of these tests can be used to determine whether the wall needs to be repaired or replaced. In addition to physical barriers, other measures can be taken to prevent the spread of flammable gases or vapors. These measures may include ventilation systems, gas detection systems, and fire suppression systems. Ventilation systems can be used to remove flammable gases or vapors from the air, preventing them from accumulating to dangerous levels. Gas detection systems can be used to detect the presence of flammable gases or vapors and to alert personnel to the potential hazard. Fire suppression systems can be used to extinguish a fire in the event that one does occur. A comprehensive safety plan should include a combination of physical barriers and other measures to provide the best possible protection against the hazards of flammable gases or vapors. This plan should be reviewed and updated regularly to ensure its continued effectiveness. In conclusion, maintaining the integrity of barrier walls in hazardous locations is critical to preventing the spread of flammable gases or vapors and ensuring the safety of personnel and equipment. This requires careful attention to the construction of the wall, the sealing of penetrations, and the regular inspection and maintenance of the wall. By following these guidelines, it is possible to create effective barriers that protect against the hazards associated with flammable gases or vapors. In situations where conduit containing 24 volts direct current circuits pierces a wall between a Class 1, Division 2 area and an unclassified area, the primary concern is preventing the migration of flammable gases or vapors from the classified area to the unclassified area through the conduit penetration. While the 24 volts direct current circuits themselves are unlikely to pose an ignition hazard, the conduit penetration can create a pathway for gas migration if not properly sealed. Therefore, the focus should be on ensuring that the conduit penetration is effectively sealed to prevent the passage of gas. The materials used to construct the wall, such as the vapor barrier, fiber-reinforced polymer, and drywall, contribute to the overall fire resistance and gas tightness of the barrier. However, the effectiveness of the wall depends on the integrity of the seals around any penetrations. The use of fiber mesh tape and non-sanded mud helps to create a smooth, even surface for the wall, but it does not provide a gas-tight seal around the conduit penetration. Therefore, additional sealing measures are necessary. The NEC and NFPA standards, as discussed earlier, provide guidance on the types of sealing methods that are acceptable for use in hazardous locations. These methods include intumescent putty, compression-type seals, foam-type seals, and combination seals. Choice of sealing method will depend on the specific application and the requirements of the applicable standards. In addition to the sealing method, the type of conduit used is also important. Rigid metal conduit or explosion-proof conduit is recommended for use in hazardous locations to provide a robust and gas-tight pathway for the electrical wiring. The conduit should be installed securely and supported to prevent any movement or stress that could compromise the seal. The sealing material should be compatible with the conduit material and the gases or vapors present in the classified area. Some sealing materials may be attacked by certain chemicals or solvents, which could degrade the seal over time. Regular inspections of the conduit penetration and sealing material are essential to ensure that the seal remains effective. Any signs of damage or deterioration should be addressed promptly. If the seal is found to be compromised, it should be repaired or replaced immediately to prevent the migration of gas. In addition to sealing the conduit penetration, it may be necessary to take other precautions to prevent the migration of gas. This may include pressurizing the unclassified area with clean air to create a positive pressure differential that prevents gas from entering the area. It may also involve installing gas detectors in the unclassified area to provide an early warning of any gas leaks. A comprehensive safety plan should be developed for the installation, taking into account all potential hazards and implementing appropriate safety measures. This plan should be reviewed and updated regularly to ensure its continued effectiveness. In conclusion, while the 24 volts direct current circuits themselves may not pose a significant ignition hazard, the conduit penetration between a Class 1 Division 2 area and an unclassified area must be properly sealed to prevent the migration of flammable gases or vapors. The sealing method should be chosen in accordance with the NEC and NFPA standards, and regular inspections should be conducted to ensure the continued effectiveness of the seal. Additional precautions, such as pressurization or gas detection, may also be necessary to provide a comprehensive level of safety.